When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. In this video, we're going to cover this exam question, which comes from the Ester chapter. While doing a second, I'll read the actual question. Once I read the question, give about 5 seconds to pause the video. Once you pause the video, attempt the question, and then press play when you're ready. The question itself is this. Explain the trends in the boiling points shown in the graph, and that's for 4 marks. And on the y-axis, we have the boiling point. So this is the boiling point in degrees Celsius. And on the x-axis, we have the molecular weight in grams. So that's this here. Molecular weight and boiling point. And we've got alkanoic acid, alkanols, and alkenes. And the question is explain the trends in boiling points shown in the graph for 4 marks. When you're ready, pause the video and attempt the question. Welcome back. Alright, for the answer for this one, what you should do is first you should mention why they're all increasing as you increase the molecular weight, and that's connected to the chain length being longer with the more higher your molecular weight, and that means you have more dispersion forces. So that should be your first point of reference. You need to have it in your answer somewhere. It doesn't have to be the first, it just has to be in the answer somewhere. You need to make sure you talk about increasing molecular weight being linked to your increasing chain length. And that means there's going to be more dispersion forces, which means the boiling point will have increased. Then what you should also do is you should talk about why the alkenes are the lowest on that list, lowest boiling point. And that's because they have hydrocarbons, which means these hydrocarbons only have dispersion forces. And that will mean that they have weaker bonds compared to the alkanols and alkanoic acids, because the other two have dispersion forces plus hydrogen bonds. Then you talk about the alkanols, why they're higher than the alkenes but lower than the alkanoic acids. And that's because the alkanols have dispersion forces plus hydrogen bonds. One hydrogen bond, so I'll write a hydrogen bond referring to one on the hydroxide group. And then why did the alkanoic acids have the highest? That's what you also need to talk about. The alkanoic acids, they have dispersion forces like the other ones do. But on top of that, what they also have is they have more than one hydrogen bond possible. They actually have 2 possible hydrogen bonds. So I write S for 2. So in your answer, you need to go for these 4 points. And as you can see, it's for 4 marks. So you will get a mark for each of those points. So what I wrote first is the boiling point increases for alkanoic acids, alkanols, and alkanes as the molecular weight increases. This is due to the increasing chain length that accompanies the increasing molecular weight. So as we increase the molecular weight, we also increase the chain length. That's what that's suggesting. An increasing chain length results in more dispersion forces between the chains, and thereby increasing the boiling point because we have a stronger bond, because we have more dispersion forces. So that's why for each of those 3, as we go higher molecular weight, we also increase our actual boiling point. Now the next point I made was about the hydrocarbons, why they are the lowest. Alkanes have the lowest boiling point of the 3. This is because alkanes are hydrocarbons. They only have weak dispersion forces acting between the chains. So they only have the weak dispersion forces, that's it. Thereby being relatively easy to break, which results in the low boiling point. So because they have only dispersion forces, they have relatively weak forces, which are easy to break, and thereby have a lower boiling point. So now I talked about the overall chain length and the hydrocarbons. I'm just going to talk about the other 2. So now the alkanols parts. Alkanols, on the other hand, have dispersion forces and hydrogen bonds occurring. So here they have dispersion forces and hydrogen bonding occurring. The hydroxide group, which is the alcohol group, allows for hydrogen bonds to occur between close by chains. You know what I mean? Resulting in a stronger bond than merely dispersion forces, which explains their higher boiling point when compared to alkanes. So in this case, they have higher boiling point than alkanes because they have dispersion forces plus hydrogen bonds. And the hydrogen bonds are relatively strong, thereby they have the higher boiling point. Now for the last one, I wrote talked about the alkanoic acids. Alkanoic acids have two sites that can form hydrogen bonds, as opposed that's the carboxylic acid group, as opposed to alkanols that have only one. So we've got two for the alkanoic acids and only one for the alkanols. This gives the alkanoic acid additional intermolecular bond strength, which explains the higher boiling point. So the alkanoic acids have the highest boiling point because they can do two hydrogen bonds plus dispersion forces. The alkanols are next because they can do only one hydrogen bond, but they also have dispersion forces. The alkanes are last because they can only do dispersion forces because they only have hydrocarbons in their chain. Where that substop point come from, or the question come from, it came from this dot point. Explain the difference in melting point and boiling point caused by straight chain alkanoic acid and straight chain primary alkanol structure. So in this case, we should compare the alkanols and the alkanoic acids according to that dot point. And the alkanes is just something you have to know from previous dot points all the way back to the production of material module. I hope that was useful.
Thank you for watching.